Welcome to the next part of the tutorial, that is assembly modeling. Now in assembly modeling we are going to study these many parts or these many assemblies: press tool assembly, wheel support assembly, fixture assembly, pulley support assembly, and knuckle joint assembly. We'll start with the press tool assembly. So this here is the assembly of the press tool assembly. Now it consists of these many parts. The base here is the bottom plate. It includes the top plate. You can see here a punch like structure. So basically this is used for sheet metal working. A flat sheet is inserted between the top plate and bottom plate. See, the top plate, it slides along these pillars, and these pillars are called as guide pillars. And in between the top plate and the guide pillars, guide bush are inserted so that the friction is reduced. So this may be made up of cast iron, this may be made up of high carbon steel, or high speed steel. This may be made up of, or the guide pillars may be made up of high carbon steel, and the bushes, they may be made up of bronze or brass material. So to start the assembly, we will have to create the individual parts first and then assemble them together. And during the assembly we will select the bottom plate as our base part. So we'll start with the bottom plate first. So these are the dimensions of the bottom plate. The thickness of the plate is 30 mm, the width is 250, this height is 150, and you are seeing this from the top view. So we'll start creating. First we'll create or set our working directory, and I have already created a folder. I've named it as PTA, that is press tool assembly. I'll select it and say OK. I'll create my first part, that is the bottom plate. So I'll name it as bottom plate, part solid bottom plate. Select MMNS part solid and say done. Now we have to create the bottom plate of thickness 30 mm. So we'll create using extrude tool. Go to placement, define. The diagram shown was the top view, so we'll select the top view, sketch. We'll try to use the symmetry maximum to the possible. So to use the symmetry, we'll create the center lines. Two center lines, that is one horizontal and one vertical, and then we'll create a rectangle such that it is symmetric about the horizontal line as well as symmetric about the vertical line. The distance is 250 and this distance is 150. Similarly, there are circles. The diameter of the circle is 25. This distance is 30 and this distance is also 30. So basically the guide pillars are inserted inside this 25 mm holes, diameter holes. So the diameter of the guide pillar is 25, so they are inserted inside this 25. On the top plate you can see the holes are of diameter 40. So inside these holes this guide bush is inserted. So the outer diameter of the guide bush is 40, inner diameter is 25. So the guide bush is of diameter 40, outer diameter, so it is inserted inside the top plate, and again in the inner hole the guide pillar is inserted where the inner diameter is 25. So we have created one hole and we know that we can use the mirror tool. So select the mirror tool, specify the center line. Similarly select these two circles and specify the center line. There is another hole which is of diameter 50, and the distance of the center line of this hole is 50 from this edge. So create a circle which is of diameter 50 and then specify this distance which is 50. So now we want to extrude this by 30 millimeters. So specify 30 and say done. So as discussed, it may be made up of cast iron. So go to properties to specify the material, select change, and since cast iron is not present, we can add the material, say cast iron, and its properties as well. So by substituting those properties, we can find out the volume, surface area, its mass, and likewise. But right now we are not interested in it. We'll simply specify the material as cast iron and save. So the material is added. We'll say OK. Close this and then save it again. So save and say OK. So our first part is ready. We'll close this first and then we'll start creating the next part. The next part is the top plate. Name it as top plate. Part model. So subtype is solid. Again, to create the top plate, you can see just like how we have created the bottom plate, we can create this upper part of the top plate, but we'll again have to use extrude tool to create this cylindrical part. So we'll have to use the extrude command twice. So go to extrude, select placement, define, again select top and say sketch. We'll repeat the same steps: a horizontal line, a vertical line, a symmetric rectangle about both these axes. This dimension is 250, this dimension is 150. However, the size of the hole now is 40 mm. So this is 40, this distance is 30, this distance is 30. Now create the mirror images. And say done. The thickness is 30, say done. So this is the standard orientation. This is our top plate, and here we want to add this sponge material or cylindrical material, which is able to create holes inside the sheet. When a sheet is inserted in this, the top plate will travel along the guide pillars in longitudinal direction and press out the blanks or press out the holes inside the flat sheet materials. So when you see this in from top view, the cylindrical structure, it would appear as a circle, right? It is shown here in dotted line. That means it is hidden, and it would appear in the lower half. But when you see it from the bottom view, it would appear in the upper half of the rectangle. So let us select extrude tool, placement, define, and select the bottom surface. Select sketch. Now select the circle or draw a circle. Diameter of the circle is 50 and this distance is 25, or this distance is 50, or this distance from center line is 25. Say done. Now the distance to be extruded is 90 and say done. So because it has to withstand higher forces, this part is usually made up of higher strength materials. So you'll add material, go to properties, select change. Let us say we want to add high speed steel, which is not available in our library. So we'll add the material, high speed steel, and say save. Select OK, select close, and now save this file again. Save and OK. So top plate is ready. We can close this. Next, we want to create the guide bush and guide pillar. So this was our top plate. Let us open it first. We can color it so that it becomes easier during the assembling process. Let us say we are coloring it with red. So in this section here, select part and select the part. Press the middle mouse button to select it and say save. Say OK. Let us close this. And similarly, we'll open our bottom plate. You can see its preview here. Select open, select the color here, let us say this color, green color, select the part, say done. Now save it first and then close. Now we have to create the guide pillar. So select part, solid, guide pillar. The guide pillar is vertical. So to create this, what we can do is select extrude, select placement, define, set top plane. When we extruded the top plane, the part will become vertical. So its axis will become vertical. Select sketch, draw a circle. The diameter of the guide pillar is 25 and its length is 200. Set done. Now the guide pillar have this chamfered edges. The specifications are 2 into 45, that is they are of 45 degrees. So select chamfer tool, select 45 into D, specify the value of D, that is 2, press the control button and select these two edges. Hit done. Go to properties. So as discussed, this material, it may be high carbon steel. So let's specify high carbon steel and say save. Okay, and close. Let us also color it. So done. Let us save this. Okay, and close this. Next, we want to create the guide bush. The inner diameter is 20, outer diameter is 40, and the length is 60. So, file, new, create guide bush. Say OK. Go to extrude, placement, define, top plane, select sketch, create a circle, specify the diameter 25, and create another circle with diameter 40. Set done. Specify the distance 60. Set done. Again select chamfer, select 45 into D, select these two edges, set done. Color it and specify the material. Let us say material is bronze. Add the material bronze and say OK. Close this and save it again. Now let us close this file and start creating the assembly. So again select new, assembly, press tool assembly, say OK, select MMNS assembly design and say OK. We will start by creating or adding the base plate first, and on the base plate we will add the remaining parts. So select this assemble tool, select the bottom plate. So you can see the preview here. Select, say open, and now you can see that it is not fixed at a place, or the status mentions that it is not constrained. That means you can move it around anywhere, right? So this is your origin of your coordinate system and you can move it anywhere. So this makes it very difficult to assemble the parts together because they will have relative motion with respect to each other, and we want to fix that relative motion, that is we want to fully constrain them. So in order to make that, usually the general practice is to fix this part as it is, which was done in its original file, that is default. So the first part is usually constrained by using default. So now you can see that it is fully constrained, and when we go to move, we are not able to move it, right? It is fully constrained. So select done. So this part is now constrained, fully constrained. We'll add the guide pillar, go to assemble, select the guide pillar, select open, and now we want to insert this guide pillar, that is we want to align these two axes. Go to placement, select align, select this axis and select this axis. They are aligned together, but it is saying that it is partially constrained, that means it is still having some amount of relative motion. What is that motion? So you can see that you can still translate it, right? So that means it will have relative motion. To fix this, go to placement, select new constraint, select align, select this bottom surface and bottom surface of the bottom plate, and now it is fully constrained. So that means it will not have any relative motion. Next, we will add the guide bush. So select assemble, select guide bush, select open. Now let us align these two axes. So select align, select this axis and this axis. Similarly, we want this top surface of the guide pillar and top surface of the guide bush at a certain distance. So we'll add new constraint. Let us say align, and let us say at offset distance. Select the top surface, select this surface and specify the distance. The distance is not given in the diagram. We will randomly or specify the distance as 25 and say done. So we have added this part now. Similarly, we can manually add the guide pillar and guide bush at remaining 3 locations, or we can use the pattern command. To use the pattern command, what we can do is select guide pillar, press the control button, select the guide bush. So now both are selected simultaneously. Right click here and say group. So you can see that these two parts have now been grouped together. So these are the grouped parts, that is guide pillar and guide bush. So select this group, select pattern. Instead of dimension pattern, select the direction pattern. So you can select two directions or you can select single direction. Here we want two direction pattern. So the direction in which you want to create instances, multiple instances, you will have to select one reference line. So we want to create direction or we want to create pattern in this direction, that is two holes in the direction and two holes in this direction. So for reference, we will select this edge. The direction of arrow is in this direction. We want the arrow in this direction. Select this edge. Instead of select on this arrow, we will flip the direction using this button here. So the direction is flipped. Now the distance between this hole and this hole given is 190. We'll specify the distance, that is 190. So this will create two holes at a distance 190. Similarly, we want a pattern in this direction or direction pattern in this direction. To select, click on this space here, and for reference select this edge. So the direction of this arrow is correct and the distance is 90. Let us check it. Yes, so distance is 90. So this distance is 190 and this distance is 90. So by using this direction pattern, we have created 4 entities. We can also create multiple entities. So for example, if I say I want 3 by 3 direction pattern, it means it will create these many entities, that is 9 entities. However, we want a 2 by 2 direction pattern, so we'll select 2 by 2 and say done. So we can see, instead of manually creating the guide pillar and guide push and constraining them, we have used the direction pattern and simplified the process. Now next we have to add the top plate. So go to assemble, select the top plate, open it. Now we want to align this axis and this axis. Go to placement, select align, select this axis and select this axis. Similarly, we want to align this top surface of the top plate and this top surface of the guide bush. So go to constraint, select align, select the top surface and select this top surface. They have been aligned and they have also been fully constrained. That means they will have no relative motion. You can see the plate does not move. Press done. So in this way we have assembled our first assembly, which is the press tool assembly. So if this is disturbing or if this is complicating things, you can turn it off. That is, turn off the planes axis and likewise. Let us save this. So save, press tool assembly and OK. Now let us create the 2 drawing sheets. One is the details sheet and one is the assembly sheet. So go to new, select drawing, let us say details, or let us say assembly, select OK. I have already created a format. You can also create a template for yourself so that you will not need to every time create a table regarding your details. Say open, say OK. So I've already created this template and now I'll add my assembly here. To add assembly, select general, say OK and insert the assembly here. Select isometric view and say apply. Say close. Next, we want to add the bill of materials. So go to table, create a table using this button here. Then select the number of columns by pressing. Let us say this is first column, this is second column, third column, and this is fourth column, and say done. Similarly, first row, and second row, and say done. So in this column here, I want the serial number. In this column, I want to have the part name. In this column, I want the material of the part. And here I want the quantity of this. Say OK. Now select the second row. So what we can do is we can manually add the text here, or we can automatically insert the names of the parts as per our naming. So select the first cell here, select the select row button and right click on this, say add repeat region. Next, select repeat region, then select the attributes, then select this row here, select no duplicates and say done. Say done here. Now select the first cell, right click on it, select report parameter, go to report, select index, select the second cell, right click, report parameter, assembly, member and the name of the member. Similarly, third cell where we want to add the material, select report parameter, go to assembly, go to member, go to PTC material and select PTC material name. And on the last cell, select report parameter, say report and say quantity. So this is done. Now I'll say update table. So automatically the details have been inserted. So we have this bottom plate made up of cast iron and it is in one quantity. Next we have guide bush which is made up of bronze and it is 4 in quantity. Then guide pillar which is of high carbon steel and it is again 4 in quantity. Okay, likewise. Next we'll add the balloons. So select BOM balloons, select the table here, select create balloons and say done. To add the balloons, go to BOM balloons, select the BOM balloons, select create balloons, select the assembly and say done. So the balloons have been added. You can change its location. So 4 is the top plate, number 2 is the guide bush, number 3 is the guide pillar and number 1 is the bottom plate. So this creates the assembly sheet. We can name this as assembly of press tool assembly. You can add your name, class, roll number and then go to publish and publish in PDF format. Say OK. And then you can adjust the size of the font if you want. For example, here you can see this table, it needs more width. So to do so, we can add it, go to table, select this column here, go to height and width, select the width here, let us specify the width, say 60, go to preview and say OK. You can keep on adjusting it as per your requirement. So now you can publish it with better details. So this is the assembly sheet, and just like this you need to create another sheet. Let us save this first. And close it. Next, we want to create another sheet for the same practical. So we'll create drawing, say details, of press tool assembly. I will select the same template which I have created earlier, say OK. And here I will keep on adding one by one all the parts of my press tool assembly. So earlier was the assembly sheet, this is the details sheet which includes individual parts with their dimensions. So go to drawing models, go to add model, we'll add one by one. Let us first add the bottom plate, say OK. So from this, now we'll select the bottom plate first, select general, select inside the sheet, select the top plane, say apply. Next, go to view display, go to hidden, again say apply, say close. Let us move it. Let us create one more projection for this so that it is easier to apply dimensions. So from this view, we can know the thickness of the sheet or thickness of the plate. Then we can add the dimensions. Go to annotate, select these two views by keeping the control button pressed and select show model annotations. So select all, say OK. If you want, you can adjust them. Similarly, next we will add our other view. Now while annotating, if you want, you can also add the tolerances. For example, I want the tolerance for this hole. Right click on it, go to properties. Here say tolerance mode, plus minus, and you can say the desired tolerance limits. So let us say 0.05 mm and 0.05 mm. Say OK. So in this way you can add the tolerance limits, and then we can add the remaining parts as well. So go to layout, drawing models, set model. I will add the bottom plate, go to general, click inside, select the top view, say apply, view display, select hidden, say apply. Close this, we can move this. Similarly, we can add the remaining view. For example, now this is the top view. Instead, we can add the front view first. Let us delete this, general, click inside, say front view, say apply. This is the front view. Okay, so this is instead we have added the bottom plate only. Select the top plate, general, yes. So this is the top plate. Select the front view, say apply. Now the front view has been added, and say select view display, select hidden, and say apply. Close, move this. Now we have to add the top view. So select projection and select this. So this is the top view. Select view display and select hidden. Say apply. Okay. So this here you can see this circle here is appearing somewhat grayish in color. That means it is hidden part. Select close. If you think that this is not the top view, which is or this is not as per the front angle projection method, which is shown here by the symbol, you can change this here. Go to file, go to drawing options, search projection type here, select enter, and here you can see what method we have selected. For example, currently this is or the ProE usually takes third angle projection method as default. You can select it as first angle method and select apply. So now all the projections will be by first angle projection method. Let us annotate this part. Select these two parts, select annotate, and select the required dimensions. Only those dimensions which are required or necessary. So this some of the dimensions are common, we can ignore them, but some of the dimensions are necessary, so we'll add them. That's it, done. Next we will add the guide pillar. Select the front view, maybe let us see. So this is the front view. Okay, and let us take one more projection for this. And then annotate them. So specify all the dimensions and close this. And the last part is the guide bush. Let us maintain uniform scale. Take its projection. and then annotate it. Now let us publish this sheet. So earlier was assembly, this one is details. Before publishing, let us add the title. Go to table, say details of press tool assembly, and say OK. Now we can publish this. So if you want, you can add more tolerance levels or tolerance limits likewise. So this is how we have completed the press tool assembly. So that's it for now. Thank you.